So there are a couple of different summation properties that are useful, and these are actually fairly similar to at least some of them are kind of similar to the linearity properties that we already know for derivatives. So the first one is that if I have just some arbitrary functions of k, I've written them as a sub k and a sub and b sub k. If I have the sum of ak plus bk, I can break that up into two different sums. To show you why that is, in other words, let's suppose that I have the sum from k equals 1 to 3 of k plus k squared, like that. So if I write this out longhand, that's going to be 1 plus 1 plus 1 plus, sorry, 2 plus 4 plus 3 plus 9. In other words, that's k equals 1, k equals 2, k equals 3. I'm just replacing k with 1, 2, and 3 there. So what I could do is I could rearrange this because we know that addition commutes. So this could be written as 1 plus 2 plus 3. Again, just borrowing these terms here. And then I could write that as 1 plus 4 plus 9. And now I'm just crossing out the squared terms there and putting them in the second parentheses. But we can easily see that this is just equal to the sum from k equals 1 to 3 of k, and then plus the sum from k equals 1 to 3 of k squared. So you can see that I can just break this up because all I'm doing is really rearranging terms when I do that. That works the same, by the way, if we have the sum from k equals 1 to n of ak minus bk. I won't do that example, but it works exactly the same. You're just rearranging the terms when you do that. So that brings us to the constant multiple rule. So what that says is that if I have some arbitrary function of k, which I'm calling ak, and it gets multiplied by a constant c, I can pull that c outside of the summation. What you'll see is this is really just the distributive property that you already know. If I were to write, let's say, the sum from k equals 1 to 4 of k squared, well, let's write it as 4k squared, where 4 is the constant and k squared is what I'm calling ak. This would be um, if I expanded this, this becomes 4 times 1 plus 4 times 4 plus 4 times 9 plus 4 times 16. In other words, 1, 4, 9, and 16 are just the first four squares going from 1 up to 4. But we know that by the distributive property, I can simply write this as 4 times 1 plus 9 plus, or sorry, 1 plus 4 plus 9 plus 16. And we can see that 1 plus 4 plus 9 plus 16 is just the sum of the first four squares. So I can rewrite this as 4 times the sum from k equals 1 to 4 of k squared, like that. So that's how that rule works. Is if I have a constant, I can just pull it outside. Now, the sum of constant rule it's actually the easiest rule, but it's a little harder to see because it's maybe a bit more abstract. So what this means is that if c is some constant, and I'm just adding it up from k equals 1 to n, that's the same as just multiplying the constant by n. Now you might say, well, what does that even mean to add up the constant from k equals 1 to n when there's no k at all in here? That's kind of the point, is that if I say the sum from k equals 1 to 3 of, let's say, 9, well, if I write it out, I'm going to have three terms. I'm going to have k equals 1, k equals 2, k equals 3. Well, let's look at the term. It's 9. Every place I see a k, I replace it with a new value of k. So all 0 instances of k that appear here, I replace them with k, which means I don't replace them with anything. And it just becomes this 9. And then I do it again. I replace all the instances of k with 2. There aren't any in that expression 9, so I just write the 9. And again, I do that. So in other words, this is just 9 plus 9 plus 9, which is 3 times 9. So that's why adding up from k equals 1 to n of a constant is just n times that constant. So let's use these properties and some other things that we know to evaluate a summation like this. So what I'm going to do is I'm going to use first the sum rule to break this up. This becomes the sum from k equals 1 to 100 of 2k plus the sum from k equals 1 to 100 of 3. Next, I'm going to use the constant multiple rule to take this 2 outside of the summation. So that's going to be 2 times the sum from k equals 1 to 100 of k. And then sorry, that's the constant multiple rule, and then I'm going to use the sum of constant rule to evaluate this second summation. This is just 3 added to itself 100 times, so that's just going to be 3 times 100, or 300. Or I should write it the way that I did in the rule. We'll write it as 100 times 3, and of course that's just going to be 300. Now, we know how to add up the first 100 terms. This is simply going to be 2 times, using the rule that the sum of the first n terms is nn plus 1 over 2. That's going to be 100 times 101 over 2. And then this is 100 times 3 is 300. So this is going to be 100 times 101. These 2's cancel, so that's going to be 10100 plus 300, and this comes out to 10400. So that's the sum of that. That's the sum of that expression. Let's do one that's a little bit more complicated. Let's add up the sum of from k equals 1 to 10 of k over 3 plus k squared over 2. So this is going to be, using the sum rule, this comes out to the sum from k equals 1 to 10 of k over 3 plus the sum from k equals 1 to 10 of k squared over 2. Each of these is just like multiplying, the k over 3 is just like multiplying k by 1/3, and k squared over 2 is like multiplying k squared by 1/2. So this is going to be 1/3 times the sum from k equals 1 to 10 of k over 3, sorry, not k over 3, of just k, and then plus 1/2 times the sum from k equals 1 to 10 of k squared. Using what we know about the sum of the first k terms and the first k integers, or rather the first 10 integers and the first 10 squares, that's going to be, for the first summation, we have 10 plus 1 is 11 over 2, and then for the k squared terms, we have 1/2 times, that's 10 times, that's n plus 1, 2n plus 1, so that's going to be 10 times 11 times 2 times 10 plus 1 is 21 over 6. So this comes out to, let's see, it's going to be 10 times 11 over 6 plus 10 times 11 times 21 over 12. We can simplify this a little bit by pulling out a factor of 10 times 11 over 6. So that's 10 times 11 over 6 times 1 plus 21 over 2. You can check why 10 times 11 times 21 over 6 times 2 is exactly that term there that we have. And this comes out to 110 over 6 times 23 over 2. And let's see. I just want to do an example in which the starting point isn't 1. So let's evaluate the sum from k equals 10 to 100 of k. So the thing to recognize about this is that what I'm doing is I'm adding up 10 plus 11 plus 12 plus dot 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 plus 99 plus 100. But I could write this in the following way. I could write it as 1 plus 2 plus 3 plus dot 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 all the way up to 9 plus 10 plus 11 plus 12 plus dot 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 plus all the way up to 100, where I'm adding up the first 100 terms, but then I'm going to subtract out the first 9 of them because I want to start at 10. So this is going to be, in other words, this expression here, 10 to 100, is going to equal the sum of the first 100 terms minus 1 plus 2 plus 3 plus dot 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 plus 9. So what I'm going to do is I'm going to take the first 100 terms. Why do I want to do that? Because I have a formula for adding up the first 100 terms. And then I'm going to subtract the first 9 terms, like that. This is nice because I have a formula that gives me this, and I also have a formula that gives me that. So this is going to be 100 times 101 over 2, that's the formula for the first 100 terms, minus 9 times 10 over 2, that's the formula for the first 9 terms. So we already know that the first 100 terms is just 50/50. And the sum of the first nine terms. 9 times 10 is 90 divided by 2 is 45. So I'm going to subtract 45 from that, and I get the sum 5005. So this is how you would deal with adding up some terms where you're not starting with one. You would just you would add them all the way up to the highest number and then subtract out the ones you don't need, where the subtraction is just going to be another summation that you can calculate in this way.